13.8 billion years ago, everything we know exploded into existence from a point smaller than an atom. But the James Webb Space Telescope just found galaxies that were already ancient when the universe was supposedly still a baby. We're seeing stars that formed heavy elements before the cosmos had time to cook them. Massive black holes that grew impossibly fast. And structures so perfectly organized they shouldn't exist in a chaotic young universe. The most powerful telescope ever built wasn't meant to destroy our origin story, but that's exactly what it's doing. Prepare yourselves. We begin. James Webb Telescope. The James Webb Space Telescope cost $10 billion and took 30 years to build. But this wasn't just about getting better space photos. Scientists had a specific mission: prove that our story of cosmic creation was absolutely correct. For decades, we've told ourselves a simple tale. The Big Bang happened 13.8 billion years ago. Then came 400 million years of cosmic darkness. While the first stars slowly formed, those early stars were supposed to be simple, made only of hydrogen and helium. Galaxies should have grown gradually, messily, over billions of years through countless collisions and mergers. This timeline wasn't just theory. It was the foundation of modern cosmology. Every textbook, every documentary, every explanation of how we got here relied on this sequence of events. The James Webb Telescope was designed to be the ultimate witness. Its infrared vision could peer back to the cosmic dawn and show us those first primitive stars struggling to ignite in the darkness. We expected to see a chaotic, violent universe slowly organizing itself into the cosmos we know today. The telescope's mirrors were polished to perfection. Its instruments calibrated to detect the faintest whispers of ancient light. Scientists prepared to celebrate as observations confirmed what computer simulations had predicted for decades. The early universe should look young, disorganized, and exactly as messy as you'd expect from a cosmos just learning how to exist. But when James Webb opened its golden eye and looked back toward the beginning, the cosmic dawn of time, it didn't find confirmation. Instead, it discovered something that made astronomers question everything they thought they knew about cosmic history. The telescope that was meant to prove our origin story might instead destroy it completely. What we found challenges not just the details of how galaxies formed, but the entire timeline of cosmic evolution. The implications reach far beyond astronomy. If our most fundamental story about reality is wrong, what does that mean for physics, philosophy, and our place in the universe? The discoveries waiting in James Webb's data might force us to rewrite the very first chapter of existence itself. But that's just the beginning of what we found staring back at us from the cosmic dawn. 400 million years after the Big Bang, the universe should have been a cosmic wasteland. Think of it like this. If the entire history of the cosmos was compressed into 1 year, we're looking at January 2nd. At that point, galaxies should be tiny, primitive collections of the very first stars. What James Webb found instead were massive, mature galaxies that looked like they'd been around for billions of years. These aren't small collections of newborn stars struggling to survive. We're seeing galaxies with masses equivalent to 100 billion suns, perfectly organized into spiral arms and central bulges. To put this in perspective, our own Milky Way galaxy took over 13 billion years to reach this level of development. Yet here are galaxies that somehow achieved this complexity when the universe was barely out of diapers. The numbers don't add up. Computer simulations show that galaxies this massive should take at least 2 billion years to form through the slow process of smaller galaxies merging together. But we're seeing them when the universe was only 400 million years old. It's like finding a fully grown oak tree in a garden that was planted yesterday. Dr. Ivo Lab from Galaxy Monsters, Swinburne University, described these discoveries as galaxy monsters that shouldn't exist. His team found galaxies so massive they make up almost as much matter as all the stars that should exist in the entire observable universe at that time. The math simply doesn't work with our current understanding of cosmic evolution. Even more puzzling is how organized these galaxies appear. The Big Bang Theory predicts that early galaxies should be chaotic and irregular, slowly forming structure through gravitational interactions over cosmic time. Instead, James Webb is showing us galaxies with clear spiral patterns, central black holes, and organized star formation regions. These are features that should take billions of years to develop. This discovery is forcing astronomers to confront an uncomfortable possibility. Either our understanding of how fast galaxies can form is completely wrong, or our timeline of cosmic history needs a major revision. Some scientists are beginning to whisper about alternative theories that could explain these observations. But accepting those alternatives means abandoning much of what we thought we knew about the universe. The implications stretch beyond just galaxy formation. If massive galaxies existed this early, they would have influenced the entire structure of cosmic evolution. The gravitational effects of these monster galaxies should have left traces throughout the universe that we simply don't see in other observations. Yet, the evidence keeps mounting that these impossible galaxies are absolutely real. In the beginning, the universe knew only 3 elements: hydrogen, helium, and tiny traces of lithium. Every other element in the periodic table had to be forged inside the nuclear furnaces of stars and scattered through space when those stars died. This process takes time, billions of years. Yet, James Webb is finding heavy elements in galaxies that formed when the cosmos was still a cosmic infant. Picture a star as a cosmic kitchen. It starts with simple ingredients, hydrogen and helium, and slowly cooks them into heavier elements through nuclear fusion: carbon, oxygen, silicon, iron. All these elements, heavy elements, require multiple generations of stars to create. The first stars had to live their entire lives, explode as supernovas, and seed space with heavy elements before the next generation could form planets and more complex chemistry. This stellar cooking process is like a cosmic assembly line that shouldn't be rushed. The most massive stars burn through their fuel quickly and explode within a few million years. But even the fastest cosmic assembly line needs hundreds of millions of years to produce significant amounts of heavy elements. The universe at 400 million years old simply hadn't had enough time for this process to work. Yet spectroscopic analysis of these early galaxies shows clear signatures of oxygen, carbon, and even heavier elements like silicon and magnesium. The concentrations aren't trace amounts that might be explained by unusually fast stellar evolution. We're seeing metal abundances that suggest multiple generations of star formation and death had already occurred. Dr. Emma Curtis Lake, who led some of these observations, described finding galaxies with metallicities that rival much younger systems. The spectral lines don't lie. These galaxies contain elements that shouldn't exist in such quantities for billions more years of cosmic evolution. The discovery creates a cascade of problems for our cosmic timeline. If heavy elements existed this early, then planet formation could have begun much sooner than predicted. Rocky planets like Earth require these heavier elements to form. The implications for when life might have first appeared in the universe become staggering. Some astronomers are proposing that the very first stars might have been much more massive than we thought, burning through their lives and creating heavy elements at unprecedented rates. Others suggest that star formation itself might work differently in the early universe than it does today. But both explanations require us to revise fundamental assumptions about stellar physics. The elements James Webb found shouldn't exist yet, but they're there, written in the light of ancient galaxies, challenging everything we thought we knew about cosmic chemistry. What we discovered next element problem looks simple by comparison. Imagine trying to build a skyscraper during an earthquake while blindfolded. That's what galaxy formation should have looked like in the early universe. The cosmos was violent, chaotic, and filled with dark matter and gas crashing together in random collisions. Galaxies should have grown slowly and messily through countless mergers over billions of years. What James Webb found instead were galaxies that looked like they'd been designed by a cosmic architect. The Hubble Space Telescope had already shown us that distant galaxies appear more irregular and chaotic than nearby ones. this made perfect sense. We were looking back in time to see galaxies in their awkward teenage years still growing and organizing themselves. James Webb was smooth organization supposed to push even further back to see cosmic toddlers stumbling around in the dark. Instead, we found galaxies with clear spiral arms, organized central bulges, and structured star formation patterns. These features require delicate gravitational balance and billions of years of quiet evolution to develop. In our own cosmic neighborhood, only the most mature galaxies display such perfect organization. Yet here, they were in the cosmic dawn, looking impossibly sophisticated. Dr. Stephen Finkelstein from the University of Texas described these discoveries as finding adult galaxies in a cosmic nursery. The level of organization defies everything we know about hierarchical structure. Formation, which predicts that small objects merge to form larger ones over cosmic time. These galaxies appear to have skipped their messy childhood entirely. The smooth disk structures are particularly puzzling. In today's universe, galaxy disks form through a complex process where gas settles into rotating patterns over hundreds of millions of years. Early in cosmic history, frequent mergers and chaotic conditions should prevent such delicate structures from surviving. Yet, James Webb is showing us pristine spiral patterns that look like they've never been disturbed. Even more mysterious are the central supermassive black holes that seem to be perfectly coordinated with their surrounding galaxies. In the modern universe, we observe tight correlations between black hole masses and the properties of their host galaxies. This relationship takes billions of years to establish through a complex dance of feedback between star formation and black hole growth. Finding such coordination in young galaxies suggests processes we don't understand. The implications challenge the entire concept of cosmic evolution. If galaxies can organize themselves this quickly, then our understanding of how structure forms in the universe needs a complete overhaul. The smooth, organized galaxies James Webb discovered shouldn't exist for billions more years. But their perfect spiral arms are just spinning us toward an even stranger discovery about rotation speeds that break the laws of physics. Galaxies rotate like cosmic hurricanes held together by the gravitational embrace of dark matter halos that surround them like invisible cocoons. The faster a galaxy spins, the more mass it needs to prevent itself from flying apart. This relationship between rotation speed and mass is one of the most reliable rules in astronomy. But James Webb found ancient galaxies spinning so fast, they should have torn themselves to pieces billions of years ago. When astronomers measure how fast stars move in galaxy disks, they can calculate exactly how much total mass the galaxy contains. It's like watching cars on a circular racetrack. The faster rotation they go without flying off, the steeper the banking must be. In galaxies, that banking comes from gravitational mass, mostly in the form of dark matter. The problem is that these early galaxies are rotating at speeds that require dark matter halos much more massive than anything we see in computer simulations of structure formation. Some galaxies are spinning at 300 kilometers/s, when they should be limited to maybe 150. That's like finding a motorcycle taking a tight turn at twice the speed that should send it skidding into the wall. Dr. Claude Andreau-Faucher-Jaguar from Northwestern University has been studying these rotation curves and describes them as impossible under current models of galaxy formation. The dark matter halos required to stabilize such rapid rotation would be so massive, they should dominate the entire region of space around them. Yet we don't see evidence for such monster halos in the cosmic web structure. Even stranger is how quickly these rotation patterns must have established themselves. In today's universe, galaxy disks build up their rotation gradually as gas settles into stable orbits over hundreds of millions of years. But these ancient galaxies appear to have reached maximum spin almost immediately after forming. It's like finding a figure skater already in a perfect pirouette the moment they step onto the ice. The physics gets even more problematic when you consider angular momentum conservation. As galaxies form from collapsing gas clouds, they should spin up gradually as they shrink like a figure skater pulling in their arms. but the rotation speeds James Webb measured galaxy mergers suggest these galaxies started with far more angular momentum than the cosmic web should have been able to provide. Some theorists are proposing exotic solutions involving modified gravity or alternative dark matter models. Others suggest that early galaxy formation might involve processes we've never considered. But every explanation requires abandoning well-tested physics or accepting that the early universe operated under completely different rules. These spinning galaxies are rotating us toward an even more disturbing discovery about collisions that happened before galaxies should even exist. Galaxy mergers are cosmic train wrecks that unfold over hundreds of millions of years. When two galaxies collide, their gravitational dance creates tidal tails, stellar streams, and distorted structures that astronomers can recognize like forensic evidence at a crime scene. James Webb found this evidence in galaxies that formed when the universe was so young that collisions shouldn't have been possible yet. The timeline problem is severe. According to our models, the first galaxies were tiny, isolated islands of stars scattered across vast distances.